Okay, so here we are beginning chapter 5, 5.1. We'll start with trigonometric proofs. Some of these things from the previous chapter. Cosecant as the reciprocal of sine, secant as the reciprocal of cosine, or 1 over cosine. Cosecant is 1 over sine, secant is 1 over cosine. Tangent is sine over cosine, or 1 over cotangent, reciprocal of cotangent, and cotangent is the reciprocal of tangent, 1 over tangent, or cosine over sine. In terms of the unit circle, there's what are called Pythagorean identities. If you're on the unit circle, cosine and sine, as it were, there's a little triangle there, essentially. You have a little 1, your little x, your little y, if you will. Now, the x is cosine theta. And the y value, oh, here it is, I'm sorry. And the y is sine theta, which only brings you that triangle. So cosine squared plus sine squared equals to 1. Or sine squared plus cosine squared equals to 1, essentially. If you divide both sides, if you divide everything here by cosine squared, sine over cosine is tangent squared, or sine over cosine is tangent, so it becomes tangent squared, and it becomes 1, and it's 1 over cosine, which is your secant, or your secant squared. We take this whole equation and divide everything by sine squared, you get 1. Cosine squared over sine squared would be your cotangent squared, and then 1 over sine squared would be your cosecant squared. So these identities here, we're going to use these identities, and we're going to solve other identity. We're going to prove a lot of other things here. So I'm going to just do a handful of problems here, nothing fancy. Kind of walk you through some of this. The problem is cotangent theta divided by cosecant theta equals to cosine theta. So what you usually do, you start with one side and you try to prove the other side. Now, if you will, sometimes you have to work on both sides separately and get them to match somewhere in the middle. However, I'm going to start here on the left side normally. Now, cotangent is one way to write it is cosine over sine. So I'm going to replace cotangent with cosine over sine. I'm going to replace cosecant with 1 over sine. So this turns into cosine over sine divided by 1 over sine theta. Cosine theta over sine theta divided by 1 over sine theta. When you divide by a fraction, you multiply by the reciprocal. So notice that sine thetas cancel. And you're left with cosine theta over 1 or just cosine theta. Now that's what you're trying to prove. So I boxed it in to show that I've proven how to get, because you understand what the answer is going to be this one. He wants you to see if he wants to see the steps you can take. So QED means it's proven. It means that is what is to be proven. It's Latin. And to quote erat demonstratum, it's era demostrado, or what was demonstrated. So number 2 here, if I may. 1 minus sine squared beta equals cosine beta. Sorry, 1 minus sine squared beta divided by cosine beta equals cosine beta. Again, the B stands for beta, so 1 minus sine squared. Now, sine squared theta plus cosine squared theta equals to 1. So if I subtract sine squared theta from both sides, cosine squared theta equals 1 minus sine squared theta. So here, this 1 minus sine squared beta, I can replace it with cosine squared beta. So I do. So cosine squared beta over cosine beta, one of the cosines cancel, and so you have cosine. Which is what you're trying to prove. So sometimes it's a little short, sometimes it takes a while. And sometimes there's other ways of doing it. It's not the only way. But as you do this here, the next one, cosine squared alpha times tangent squared alpha plus 1. I start with the left-hand side by itself, then I'm going to distribute cosine squared. But before I distribute, I'm sorry, before I multiply by cosine squared, I'm going to take tangent squared plus 1. And I'm going to say, hey, look, it's an identity. Tangent squared plus 1 is secant squared. So I change tangent squared alpha plus 1 into secant squared alpha. So I have secant squared times alpha. Secant squared alpha times cosine squared alpha. So secant is 1 over cosine. So secant squared is 1 over cosine squared. Okay. And now cosine squared cancel, and you're trying to equal it to 1. So that's what you did. So that's how you do these proofs. There's a couple more problems, but that's essentially how you do it. Moving on, a couple more problems here. This one involves fractions. So 1 over 1 minus sine theta divided by 1 over 1 plus sine theta equals to 2 secant squared theta. So I'm going to start essentially with the left-hand side. Start with this. And I'm going to try essentially to get common denominators. So I'm going to multiply one fraction by the denominator of the other one. So the first fraction by the denominator, top and bottom by the denominator of the second one. Second fraction, top and bottom by the denominator of the first one. So multiplying across the top, it's just 1 plus sine theta. Multiplying across the top, 1 minus sine theta. The bottom, just leave them as the products, two the same. By design, they have to match, and so you can combine. So up in here, all we do is add the numerator. So 1 plus 1 is 2. The sine thetas cancel. So it's 2 over this. Distribute, you get 1 minus sine squared theta. Now, a little while ago, we learned that 1 minus sine squared is also cosine squared. So 2 over cosine squared becomes 2 times 1 over 2 times 1 over cosine squared theta. But 1 over cosine squared is a reciprocal of cosine, so that's secant squared. That's what you're trying to get. So I just wrote there QED, I've proven it. That's what it's asking for. Number 5, it has these two parentheses equal to 5. These two parentheses squared added up equal to 5. So this has two parentheses of each. So I'm going to FOIL everything. In doing so, I get 4 sine squared plus 2 sine cosine plus 2 sine cosine, which is 4 sine cosine in the middle. And then cosine times cosine is cosine squared. Over here, I get 4 cosine squared minus, because there's a minus in there, minus 4 sine cosine x, 4 cosine x sine x, and then plus sine squared. The 4 sine x cosine x's cancel. These two combine like terms. That becomes 5 sine squared x. These two also combine to become 5, but cosine squared x. Since they have a 5 in common, I'm going to factor the 5 out. Since I have left sine squared plus cosine squared, that's good because that's 1. That's a Pythagorean identity. So 5 times 1 is 5. And then number 6 here, e raised to this stuff equals to 1. So I start with e raised to this stuff, but notice that e and natural log are inverse of each other from college algebra. So you get sine squared plus cosine squared, and that's just 1. So this is what I'm trying to prove. And this is essentially how 5.1 works. How this 5.1 works. You're just trying to prove things using identities. Okay, 5.2 through 5.4, 5.2, 5.3, and 5.4, they talk about formulas. They talk about trigonometric formulas. And so I'm just going to put them all into one because they're just different varieties of formulas. The first formula we start with is what are called sum and difference formulas. Sine of A plus B is sine of A cosine B plus cosine A sine of B. Sine of A minus B is sine A cosine B minus cosine A sine B. Cosine A plus B is cosine A cosine B minus sine A sine B. And cosine A minus B is cosine A cosine B plus sine A sine B. Hold on to these formulas. Don't lose them. Keep them somewhere. Write them out. Make sure you have them. And so I'm going to do a couple problems here using these values. Using values that we can find trig functions for. And then we could plug this formula in. So cosine of 75. Going back to angles from chapter 4, we have 30, 45, 60. So we're going to talk about some formula here. So cosine A plus B, I'm going to use 30 and 45. So you understand you don't want to use like 20 and 55 because you know how to find trig functions for 30s and 45s. You want to use angles that add up to 75 which you know how to take the trig functions of. That's why 30 and 45 work out pretty good. So cosine A plus B here is cosine A times cosine B. A is 30, B is 45, minus sine of A, sine of B, so 30 and 45. Cosine 30 and cosine 45, this is from chapter 4. All this is from chapter 4 here. Cosine 30 is the adjacent side of 30 divided by the hypotenuse. So just to refresh, do this really quick here. Adjacent, hypotenuse, opposite. 45. Two triangles we had in chapter 4. Cosine of 30 is the square root of 3 over 2, ca, square root of 3 over 2, times cosine of 45, which is ca as well, 1 over square root of 2, or simplified square root of 2 over 2, minus sine of 30. 30 is so, opposite over hypotenuse. So 1/2, sine of 45, opposite over hypotenuse, 1 over the square root of 2, which is the square root of 2 over 2. So when you multiply square roots, it doesn't matter the number's different. You multiply the number inside. So on the bottom, you multiply 2 times 2. 2 times 2 on the bottom. This one times anything is the anything. When you add or subtract fractions, you keep the number on the bottom the same if it's the same. And then when you subtract roots, you can't make it square root of 4. You can't take the 6 minus 2. You have to just take the square root minus the square root and leave it as such. Sine of 15, I'm going to do subtraction. So subtraction here. You understand as well, I could do 45 minus 30 to get 15. I went a different combination. I went 135 minus 120. If you do 45 minus 30, that's perfect. There are many, many different combinations here. Many combinations. So this is sine of A minus B. So we're here. Sine of A cosine B plus cosine A sine of B. So if you will, this is sine of A cosine B plus cosine A sine of B. Just put in the formula. So sine of 135 is the same thing as the sine of 45. Sine of 45 is the square root of 2 over 2. Second quadrant sine is positive, so you're good. Cosine of 120 is the same thing as cosine of 60. 60 is ca, so adjacent over hypotenuse, 1/2. The only problem is 120 is in the second quadrant, cosine is negative in the second quadrant. Then cosine of 135 is the same thing as the cosine of 45, which is the square root of 2 over 2. But because the second quadrant cosine is negative again, so negative square root of 2 over 2. And sine of 30, sine of 60, which is sine of 120, which is sine of 60, is opposite over hypotenuse, square root of 3 over 2. So negative square root of 2 over 4 minus square root of 6 over 4, negative 2 minus square root of 6 all over 4. These are the sum and difference rules. And again, I didn't want to do a formula for each single one, but they're basically all the same thing. Okay. So now tangent. Tangent, sum rule for tangent, tangent A plus tangent B divided by 1 minus tan A tan B. Tan of A minus B is tan A minus tan B divided by 1 plus tan A tan B. So 105, we put into two angles that you can add up. And in fact, you can do subtraction if you want. It doesn't matter. I don't know, 330 minus 225 maybe. Two angles that you pick, you want to be able to get tangent and cosine, tangent, sine pretty easily, or using rules that we've done in the past. So tangent of 60, TOA, opposite over adjacent, square root of 3. Tangent of 45, opposite over adjacent, 1 over 1. So you have 1 minus 1 square root of 3, and then square root of 3 plus 1. Now we have to rationalize the bottom. So see what it is down here, 1 minus square root of 3, I'm going to put 1 plus square root of 3, which is the idea of a conjugate. So when you FOIL everything out, the bottom becomes 1 minus 3, or just negative 2. The top becomes square root of 3 minus 3 plus 1 plus square root of 3. Square root of 3 plus square root of 3 plus square root of 3 is 2 square root of 3. 3 plus 1 is 4. When you divide by negative 2, you can divide each piece by negative 2. So when you divide out here, this becomes negative 2 minus square root of 3. So tangent of 105 is negative 2 minus the square root of 3. All right, continuing on, we have double angle formulas. Cosine of 2a is cosine squared a minus sine squared a. Sine of 2a is 2 sine a cosine a. Tan of 2a is 2 tan a divided by 1 minus tangent squared of a. Or cosine of 2a, you can also have another format, 1 minus 2 sine squared of a, or a third format, 2 cosine squared a minus 1. So again, if you want to know these formulas, write them down, don't lose them. So cosine squared a minus cosine squared 15 degrees minus sine squared of 15 degrees. Notice that that's this part. So I'm going to replace it with cosine of 2a. Now the a that matches is 15, so this is cosine of 2 times 15, or cosine of 30. Cosine of 30 we know by this point, so it's the square root of 3 over 2. So you're simplifying these expressions. Now if you have this format, you see how it's like this, but the a is 75. So 2 tan of 75 divided by 1 minus tan squared of 75. I'm going to replace it with tan of 2 times 75, which is tangent of 150. Tangent of 150 TOA of 150s, but 150 has a reference angle of 30. So 30 has an opposite of 1 and a adjacent of square root of 3. So 1 over the square root of 3 becomes square root of 3 over 3. 150 is in the second quadrant, so negative. Now this one is a little bit different now. It says, suppose cosine of 2a is 7 over 8, and a ends in quadrant 2. Find sine of a and cosine of a. Well, that says if cosine of 2a, one of these three versions. So we're trying to set one of these three versions equal to 7 over 8. I chose the third version because the trig function is positive and it's only one. It doesn't have two trig functions you have to solve for. So I went ahead and used the third formula. So 2 cosine squared a minus 1 is equal to that number. I'm just replacing it. I'm just, substituting. Okay? Then I'm going to add one of both. So I want to solve for cosine of a. I'm going to add 1 on both sides, but when I add 1 over here, it's like you have to get common denominator. So really 1 is 8 over 8. So that makes 15 over 8. So 2 cosine squared a equals 15 over 8. Instead of dividing both sides by 2, let's multiply by the reciprocal, so it's easier to multiply fractions here. So the 2 cancels with the 1/2, so it becomes 15 over 16. Now take the square root of both sides. Square root of 16 is 4. Square root of 15 you can't really simplify, so just square root of 15 over 4. Now the idea is, why is this negative? Because a ends in quadrant 2. So in quadrant 2, cosine is negative, which means this is not positive, it's negative. So cosine, if you know a ends in the second quadrant, this is the reference angle. This will be the reference angle for a. Wherever a turns, this is its reference. So negative square root of 15, and then hypotenuse is 4. And then so that's your cosine. So now you get a triangle. You say negative square root of 15, here's 4. And if we do the Pythagorean theorem to find the y squared plus, again, square root of 15 and the negative cancel with the 2 with the square, so the 15 then equals to 4 equals to 16. Subtract 1 from both sides. So y is the square root of 1. It's positive 1 because it's going up. So the sine of theta, because again, you're asking for sine of a, cosine of a. We have cosine of a here. So now we use a triangle to find sine of a. Sine of a, again, opposite over hypotenuse, 1/4. And that's all there is to it, essentially. Then, as promised, more formulas. You have half angle formulas. Cosine of a over 2 is equal to plus or minus square root of 1 plus cosine of a divided by 2. Sine of a over 2 is square root of 1 minus cosine of a over 2, plus or minus. Tan of a over 2 is plus or minus 1 minus cosine a over 1 plus cosine a, or sine a divided by 1 plus cosine a, or 1 minus cosine a divided by sine of a, however you want to look at it. So cosine of 15. Now, a little while ago, we had 15 degrees and we did 45 minus 30, or, you could do 60 minus 45 would be the difference. But since we're talking about half angles, you're saying, well, 15 is half of what? So 15 is half of 30. So it's this format. So A is 30 in the problem. So this is plus or minus 1 plus cosine of 30, but now 30 has a cosine of the square root of 3 over 2. I'm going to get common denominators between the 1 and the 2. So it's 2 over 2 plus square root of 3 over 2, which is 2 plus square root of 3 over 2, divided by 2, which is 2 over 1. So you multiply by the reciprocal. That's 1/2, so it makes it 1/4. So you get this, and the square root of 4 on the bottom becomes 2. The top just stays square root of 2 plus the square root of 3. And so the idea is like, what is it, plus or minus? The tiebreaker to decide which one of these is going to be, whether plus or minus, is whatever quadrant this original angle is in. This angle is 15, so it's positive because it's in the first quadrant. So no plus or minus anymore, just the positive version. Tangent of 22.5 would be half of 45. So 45 over 2. So it doesn't really matter which one of the three. I'm going to use a third one because it only has one trig value in the bottom, not adding or subtracting, which makes it a little easier to deal with. So 1 minus cosine of 45 divided by sine of 45. This is 1 minus square root of 2 over 2 divided by square root of 2 over 2. And normally you multiply both sides by 2 over the square root of 2. You multiply by the reciprocal at the bottom. However, if I put each fraction over square root of 2 over 2, it becomes a little easier because the one on the right cancels, it just gets a 1. Here, then you flip it, so it'll be 2 over the square root of 2. But you don't like 2 over the square root of 2. So you multiply by the square root of 2 over square root of 2. You get 2 square root of 2 over 2, which is the square root of 2. So all of this ends up to just be square root of 2 minus 1. And that is tangent of 22.5 degrees. So now you can find other trig values using formulas. You don't have to use a calculator anymore. It's kind of cool. What are called product of sum formulas. If you take two trig functions that are multiplied, you can trade them in for two guys that are added or subtracted. This might not seem so obvious right now as to why that would help, but in calculus, when you try to find the area of these functions under their curves, you try to integrate them. It's come very much in handy. So if I give you the problem sine of 75 times the cosine of 15, you look for the one that says sine of A cosine of B. Or you can take this one, because the same difference. You can take the cosine. Well, anyway, just take the format that it's in. Sine of A cosine B. So it equals to 1/2 sine of A plus B. Plus sine of A minus B. This is going to fit the format A plus B, sine of A plus B plus sine of A minus B. The third formula here. So this becomes a sine of 90. This is sine of 60. Now the sine of 90 is 1. The sine of 60 is the square root of 3 over 2. So this can be written as 2 over 2. So 2 over 2 plus the square root of 3 over 2. They get the common denominators again. 1. The bottom is 2. So 2 plus the square root of 3 over 2. You multiply across the bottom now. 2 plus square root of 3 over 4. And this is your solution. Number 4, this is 8 times cosine of 105 times cosine of 75. So cosine, cosine. But notice that is this part. That's this part. So 1/2 cosine A plus B plus 1/2 plus cosine A minus B. 105 minus 75, 105 plus 75. The 8 just keeps coming along for the ride. So this is the formula, and the 8 is part of the problem, so 8 just gets multiplied to the final answer. Or 8 can multiply right now, times 1/2 is 4. This is 180. This is 30. 180, cosine of 180 is -1. So again, negative square root of 2 over 2 plus this becomes negative 2 plus the square root of 3. Now, if I cancel out a 2 here, I have a 2 left and I just distribute the 2. I get negative 4 plus 2 square root of 3. The formula part. Now, there's also a sum to product formulas. We're not going to do too much of that here. We're not going to dwell into that, but essentially will end the formulas for chapter 5.